Hello everyone, welcome back to my YouTube channel Code with Rex. Do you want to go into machine learning in Python, or you want to go into data scientist, or you just want to improve your knowledge and skills in Python? You learning Numpy is the right decision. So in this mini series, I'm going to be teaching everything you need to know about Numpy library in Python. You must have heard of the word list in Python if you are good with Python or you have been using Python. So Numpy, arrays, and lists are kind of similar, but in this course, as you go in this course, you're going to be seeing the difference and why you should use an array and not list in some situations. So these are the things we're going to be covering in this course. We're going to be going through an introduction to array, then dimension in NumPy array, and under this introduction you'll be seeing difference between a list and an array, and what an array is, and the key and characteristics of an array. We're going to be going to indexing in NumPy array. So we're going to be slicing an array, then we're going to be going to iterating a NumPy array, then we're going to be concatenating a NumPy array. I will slice it twice. And we are going to be going to arithmetic operation on NumPy array and statistics operation on NumPy array. Let's get started now. What's an array? An array is a data structure used to store multiple values in a single identifier variable name. So an array is just a data structure now that is used to store multiple values. As you can see here, my array here is storing multiple values now and is only identifying it as this my array. So we just use this my array to store all these values now. Instead of saying our normal variables now, we can just say no1 equals to 1, no2 equals to 2. That's we're having two identifier there, which is no1 and no2. But here now we're having an array storing 1, 2, 3, up to 6 in just a single identifier, which is a variable name here. It contains a collection of data elements where each element is of the same data type and can be referenced by index position in the array. So now we can see that in this array called my array, which is array is short for ARR, we set the same number. All these are the same data type, right? It's not say we are not having character here, we are not having string here, we are not having any other type of data type like boolean data type here. We only have integer here. So we can see now we cannot access each element here. We are still using this identifier, this variable name. We cannot access this element here by the index, which is the position. And then we have where my array and the index of 0 now is this one, an index of 1 is this 2, and index of 2 is this 3 here. So this is how array work. So now we are going to have characteristics of array. What are the characteristics of an array? Each element of an array have the same data type. As we've said before here in the introduction, each element of an array have the same data type. So example here now, we can see this my array here. They are of the same data type. It's just, I'm not saying that it can only be numbers, because I think, as you can see that I use numbers as example here. This also can be just names. Can just be like my names, can just be of array, and they all be string. Each element of an array is referenced using name of the array along with the index of the element. So if you want to reference each element here, you are going to use the name of the array and the index of the element you want to reference. As you can see here, we use the name of the array where my array is 0, then we are referencing to this first here. Now we can see here the name of the array and the index we want to reference. These numbers in this array are called elements. So to reference each element, we use the name of the array itself and the index of the element. An index starts from 0. That's 0, 1, 2, 3, 4, 5. So that's how we do it. So now the index of an integer is an integer value associated with the element based on the element position in the array. So what are index? Index are just, they are a value that they are associated with each element. It's an integer value that's associated with each element. So as you can see back here now, so this integer value 0 is associated with the element 1, and this integer value 1 is associated with the element 2. So this is how it works. So now the index of the first element is 0, and the index of the last element is the size minus 1. So as we've said before now, this will be 0, 1, 2, 3, 4. And you can see now we have 5 elements here, but now the first index is 0, and the last index is size minus 1. What do you mean by size minus 1? That's the size of the array. In other words, number of elements in an array. So we have 5 elements in this array now, which is telling us that the last element will be size minus 1. That's 5 minus 1. That's the last element will be the index on 4. That's 0, 1, 2, 3, 4. So this type of index is called zero-based indexing. So this is what we call zero-based indexing. So the element of an array are stored in contiguous memory location. We get more to understand what we mean by contiguous memory location as we go on. So now, what is the difference between a NumPy array and a list now? As I've said about list before, you can see array is part of NumPy module, For you to use an array, you have to install and import NumPy module for you to use an array. But list is part of core Python. You don't have to import anything, you just have to just define your variable there while using list. That's how you work with list in Python. An element in an array have the same data type. So we can see now you could either have just numbers or strings or character. This is how it works in an array. They must be of the same data type, and we will see the advantage of this very soon. And we can see element of list now can be different, can be of different data type. As you can see now, we have this array here, or this list here, 1, 2, and we have a string here, which is A. So they can be of different data type. So now, going to this now, elements are stored in contiguous memory locations. This makes the operation on array faster than list. So this element now, they are stored in contiguous memory location, and this is why any operation we are having with array are faster than when we are operating with list. But looking at list, they are not stored in contiguous memory location, and this makes the operation on lists slower than arrays. So while working with lists, our program will be slow compared to while working with an array. An array supports element-wise operation. And what do you mean by element-wise operation? We can see here now, if x is an array, it is possible to write x multiplied by 5. And what is this going to do? It's going to multiply each element of the array by 5. So if you have this now, let's say we have this 3, 4, 5 now, and we just say, and this is set to x, and we just say x multiplied by 5. Now it's going to return 15, 20, 25 as a new array for us. That's how it works. But list cannot do this. List does not support this element-wise operation because it may not be the same. So now imagine we are multiplying this by 5 now. If you multiply 1, 2, and a as a string by 5, it's going to be an error because we can multiply this 2 by 5, but this cannot be multiplied by 5. And because list does not support, can be of different data types, so it does not support element-wise operation at all. So now going to this now, array take up less space in the memory because there is no need to store data type of each element, as each element belongs to the same data type. So now NumPy array only need to store the data type of an array once. If it's an integer, it stores it as an integer or a string, and like that by default it knows that all the elements there are a string or all the element there is an integer. But coming to list here now, here where we have 1, 2, and 3, it has to store simply that the index 0, which is 1, is an integer, index 1, which is 2, is an integer, while index 2, which is a now, is a string. It has to store it specifically for each element in the list. So the list take more space in memory because it contains elements of different data type, and therefore the data of the element is also stored along with its value. So now instead of just storing these once now, it's going to store like two different things there for each element. It store the value of the element and it store the data type of the element. Why in the NumPy array here we only store the value and the data type is stored once to identify the data type of everything like that. So what are the attributes of arrays now? So as we go into NumPy array, we will be seeing the attribute of this thing we call ndim now, and this is to know the numbers of dimension axis of the array. This is not the number of dimension we have in the array, and we have shape. So shape now is a sequence of integer indicating the size of the array for each dimension. And what do you mean by dimension? We can have like 1 dimension, 2 dimension, 3 dimension. So we get to know more about that as we go on. And size now is the total number of elements in the array. Size is the total number of elements in the array, and the type is the data type of the element in the array. While item size now is size in byte of each element of the array. So these are the core and main 5 attributes of NumPy. So if you like what you've watched, don't forget to hit that like button, and if you would like to see more tutorials on Python and some features in Python, don't forget to subscribe to my YouTube channel as I will be releasing more tutorials on Python. Thank you very much.